Hello and welcome to another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler and today we're going to be doing Unit 4, Lesson 9 on additional applications of percent. So as I've mentioned repeatedly throughout this unit, percent is one of the most used topics in all of mathematics. There's hardly a branch of sort of work out there where you don't deal with percent in some way, right? And you hear it all the time in the news, when you go to a restaurant, when you go to a grocery store, anytime you buy something, anytime you sell something, there's always a tax issue, right? Or always a percent issue, which oftentimes then, gets tied in with taxes and other things like that. So today what we're going to do is we're going to look at a few different applications of percent that you're expected to know at the 7th grade level. All right. Now, a lot of times these things get messy, the numbers get kind of ugly, things like that. So we're definitely going to bring our calculator along for the ride so that we have it in order to do that kind of decimal multiplication that we often do with percentages. So make sure you have your calculator handy. But let's get right into it with the first example of an additional application of percent. Here we go. All right, so the first thing that we're going to look at is what's known as percent error. And look, it's this simple. Percent error is simply the percent that a measurement is off from the real value. In science, engineering, anything that we do where we measure something, we hardly ever measure it perfectly. So when we're trying to measure the weight of something, when we're trying to measure the length of something or the volume or the temperature or anything like that, almost always there's some kind of a error, either due to the lack of precision in the measurement, mistakes that we make, things like that. There will be mistakes. So percent error is how far off our measurement is as a percent of what it actually should be, right? As a percent of the actual value of the measurement. So let's see how that's done in exercise number 1. Kirk is measuring the length of a board he is using to make a birdhouse. He misreads the ruler and reads the measurement of the length as 23 inches. Letter A asks us, why can we not say how bad of a job Kirk has done measuring the board? Consider different lengths the board actually could be compared to what he measured. So this really gets down into kind of like a philosophical question, right? We know that Kirk's made a mistake, right? We know that he's measured the length as 23 inches. But in letter A, and I'd like you to pause the video and think about this for a moment, why can we not say how bad of a job Kirk's done? Pause the video now and try to answer the question. Well, we can't say how well of a job Kirk's done or how badly of a job Kirk's done because we don't know what the actual measurement is, right? And that really kind of boils down to it, right? We don't know the real value, right? And that's important because if the real value, think about this, if the real value is, 30 inches, right, then of course Kirk has done a pretty poor job, if he's reading off 23 inches. I mean, that's a 7-inch difference. On the other hand, right, he could have misread the ruler and the thing could have been 23.1 inches. Right? Now, if that's the true value, 23.1, and Kirk measured it as 23, he's actually not done a bad job at all, right? He's quite close to the real value. He still has an error, right? Still has an error, but it's not as big of an error as here. Or even worse, maybe the real measurement is 23 feet, right? And he just read off inches instead of feet, right? And in that case, he doesn't have a good sense for what an inch is compared to a foot, but on top of that, it's just like horribly, horribly off. Now, the question is, how do we actually measure, right, how far off he is? Well, let's start to take a look at that in letters B and C. Let me just kind of bring this up a little bit. So letter B. If the real length is 20 inches, how many inches is Kirk's measurement off by? Well, this should be pretty easy, right? We do this all the time, right? When you're talking to friends or something and you say, hey, guess how many movies I saw over the weekend? And you're like, 2. Oh man, you're off by 3 movies because I saw 5, right? The same idea here, right? Kirk measured it as 23 inches, but the real measurement is 20 inches. So Kirk is off by 3 inches, right? right? And when we say that, right, what we're really just saying is, how far away from the true measurement are we? Well, we're 3 inches away from the true measurement. But now here comes the important part, letter C. What percent of the real length does your answer in B represent? All right, so we want a percent. And we've almost always thought about percent as taking the part and dividing it by the whole. So we can say, there's 5 left-handed students in a whole of 20 students, so 5 divided by 20 is 0.25, 25% of the students are left-handed. Right? In this case, what we're really doing is we're going to be comparing this, how far off we are, which is 3 inches. That's going to be the part, right? The whole is going to be the actual measurement. I'm sorry, the true value, all right? Not the mistaken measurement, but the true value. So if I want to set up my percent ratio, what I will always do is take how far off I am, right? How far off. That's going to play the role of the part divided by 20 inches, and that's the actual. I'm trying to figure out what percent the error is of the actual measurement. And now this is easy enough, right, with our calculator. Hopefully with our calculator, we can just bring this thing out, do 3 divided by 20. Right, this will give me the decimal version of the percent, 0.15, which means we have a 15% error. All right. The percent error is always the percent of the actual value that how far off we are represents. So we are 15% away from the true value if we measure it as 23 inches, but it really should have been 20. And that can be kind of tricky because, when you set up a percent ratio, it typically is pretty easy. You're like, okay, here's the part, here's the whole, part divided by whole, multiplied by 100, there's our percent, right? But here, the part is the error. The whole is the actual amount, right? The actual thing that we should have gotten. And we do that division, and we get our percent. Let's keep going and do a little bit more work with percent error. This is really important because you're going to be in a lot of science classes where you measure things, and you may even have to calculate the percent error in your measurement. So when working with percent error, one more time, always use the error, or how far off the measurement is, as the part, and the actual value as the whole when we set up our percent ratio. Let's take a look at exercise number 2. Amy is measuring the temperature of a liquid in units of Celsius. She reads the temperature from the thermometer as 78 degrees Celsius. The real temperature is 73 degrees Celsius. Find the percent error in Amy's measurement. Round to the nearest tenth of a percent. First, find the error, and then find the percent error. All right, so the error is simply how far off we are. And that is always going to be some subtraction problem. Okay, so in this case, 78 minus 73. Simple enough, right? So our error, right, she got 78 degrees. It should have been 73 degrees. She was off by 5 degrees Celsius, right? That's Amy's error. All right, she's off by 5 degrees. Now, what's the percent error? Well, the percent error is going to be how much of the actual value, which is 73 degrees, the error represents. The 78 at this point is irrelevant, has nothing to do with it. We care about the error compared to what the actual value should have been. So our percent error is now 5 divided by 73. All right, we're going to take our calculator out. That's going to give us the decimal version, and it's going to be messy. We already know that given the fact that they're telling us we're going to have to round. All right, so this, I'm going to get my little hand icon out of there. This is going to be 0.06849, etc. So there's the decimal version. And keep in mind, right, if I really want to be able to visualize what this is as a percent, the easiest thing to do is to just simply take my calculator right now, multiply my answer by 100. All right, that will show me the percent. That's now going to be 6.8 4, 9, etc., which rounded to the nearest tenth, I'll put it right up here so we can see it, will be 6.8%. All right, almost 6.9, but not quite. 6.8% error. That's how far off we are, right? That's how far off, right, we are compared to the real value. Now, there's one more consideration when we look at percent error that I'd like to look in our last problem on percent error. Then we'll go on to other percent applications. But let's take a look at exercise number 3. The number of people in a gymnasium is 560. Victor estimates the number of people in the gymnasium and has a 5% error in his estimate. Find the lowest and the highest estimates Victor could have made. Show your work. All right, so this one's a little bit different in the fact that we know the real value, 560, and we know the percent error, 5%. So this is kind of like those problems where you're given the whole, you're given the percent, and you want the part. Except here, the part is how far off we are. So let's figure that out. That's actually pretty easy, right? So how far off, or our error, the error is going to be 5% or 0.05 times 560. And again, easy enough as long as we've got our calculator to just do 0.05, hopefully, times 560. And that gives us an error of 28. All right, specifically an error of 28 people. Now, notice it asks us for the lowest and highest estimates Victor could have given. Now, here's why it does that, right? We know, based on this total number of people and on this 5% error, that Victor was 28 people off, given his estimate. But we don't know if his estimate was too low or too high, right? So it's easy enough, right? If I want to figure out what the lowest value was that he could have gotten, well, then I'm just going to take the number of people, 560, and subtract off that 28, because that was the error. He was off by 28 people, right? And again, easy enough to do, especially if I've got my calculator just sitting here, just ready to go. Of course, that would have been a lot easier had I gotten a subtraction in. There we go. 560 minus 28 gives me 532. And the highest value, obviously, then would be the opposite, 560 plus 28. So that one I think I can do without the calculator. I think I could have done the other one without the calculator too, but that will be 588. Right, so in the first two problems what we did is that we took the measurement, right, and then we subtracted the actual, got the error, divided by the actual, and got the percent. Here, on the other hand, we're able to calculate our error by taking our actual measurement, 560, or the actual value, I shouldn't say the actual measurement, the actual value, 560, multiplying it by 0.05, the decimal version of 5%, to figure out how far off we were. The only issue in this case is that we don't know whether or not we were off on the low end, 532 people, or on the high end, 588 people. Okay. So let's go on now and look at some additional applications of percent. Now, the rest of the applications that we're going to be looking at basically boil down to what's called a fee, something that you have to pay, all right? And there are fees for all sorts of things, like a credit card, right? Something that allows you to buy something on credit, you're going to be charged a fee that's based on a percent. Or a loan. If you take money out to buy a car or a house or something like that, the bank doesn't just give you that money for free. The bank says to you, oh yeah, here's the money, but you're going to have to pay us that money back plus a little extra, and that's going to be based on a percent. And finally, there's something called a commission, and we'll talk about that a little bit more in a bit. But let's jump into exercise number 1, where we look at an interest fee based on percent. Here we go. Travis takes out a loan from his bank for $3,500. At the end of the year, Travis will need to pay back the loan along with 8.2% interest fee on the money. Determine how much money Travis will need to pay the bank after 1 year. So the simple idea is this, right? Travis needs money. He goes to the bank. He asks for a loan. The bank gives him $3,500. At the end of the year, he's going to have to pay that $3,500 back, but he's also going to have to pay 8.2% of that $3,500 back on top of the $3,500, right? So let's figure out what that is. We need to figure out what 8.2% of 3,500 is. Right? And of course, we do that by changing our 8.2% into a decimal, 0.082, which you can always do by taking that percent and dividing it by 100 on your calculator. Make sure you don't do 82%. I'm going to multiply that by 3,500. And again, this is where we love our calculator because although we could certainly do that by hand, it would take us a few more minutes than we need to. And what do we get here? We find this is equal to 287. Now, all right, let's talk about what that 287 represents. That's actually what's called the interest on the loan, right? It's an interest fee. This is the interest on the loan. It's not interesting, it's interest, all right? And that is money that we have to pay back in addition to the original amount known as the principal of the loan. By the way, this also works in reverse. If you put money into a savings account, oftentimes you will get an interest fee paid to you. Because when you put money into a savings account, believe it or not, you're actually loaning the bank that money. So the bank eventually has to pay you interest on it because they use your money to do other things. I know, it seems weird, but they do. All right, now, we're not done with this problem. Right? It says, how much money will Travis need to pay the bank back after a year? Well, it's not $287. It's $3,500 plus 287. All right. So at the end of the day, right, we still need to get our final answer, which is 3,500, because you got to pay back the original amount they owe you, plus the 287. And I think I can maybe do this without a calculator. That's going to be $3,787. That needs to be paid back at the end of the year. 3,500 of it was just what they loaned Travis, and the $287 was the interest applied to the loan. All right. Interest is an amazingly important idea when it comes to percent. All credit cards will charge you an interest rate on money that you borrow to make purchases, right? All loans that you take out for cars, houses, apartments, or any other big purchase will charge you interest. And as I mentioned, on the flip side of things, when you put money into a savings account in a bank, the bank will pay you interest. Not very much interest, definitely not 8.2% interest, but you might get 2% interest on your savings or 1.5% interest. Hey, it's something. So let's keep going. Let's talk about some more things. All right, let's talk about this thing called a commission. Now, a commission is kind of an odd thing, but they want you to know about it at the 7th grade level. So there are certain jobs in the real world, all right, where that job is to sell stuff for other people, all right? And especially like houses. There are people called mortgage brokers and real estate agents. And when they sell a house for you, you're trying to sell a house. Maybe you don't want to do it yourself because you don't have time or the ability or the knowledge or whatever, right? A person sells that house and then they get part of what you sell the house for, called a commission. And that commission is always based on interest. Another really good example is a sports agent, right? So when you've got a big-time sports star who goes out and, they get a contract for $20 million to play basketball in the NBA, right? Their agent gets a percentage of that salary, so it might be a 2% cut or a 5% cut, but regardless, it's always based on some fixed percentage. So a commission is simply a fixed percentage of an amount that something is sold for that is then given to the person who sells it for you. After all of that, let's take a look at number 5. Monica is selling a house where she earns a commission equal to 3.25% of the final selling price of the house. If Monica sells a house for $256,000, what is her commission fee? If she sold a house for only $2,000, she's not getting much of a commission fee. But anyway, all right. So at the end of the day, what we're looking to do in this case is we're just looking to find 3.25% of $256,000, right? That's what Monica is going to get, okay? Now, that percent might be the weirdest looking percent that we've worked with so far, but again, keep in mind, you can either move the decimal place 2 units to the left, or you can just take that 3.25, divide by 100 on your calculator to make sure you're multiplying by the right thing, 0.0325. So, let's not have the calculator take up all the screen, right? To figure out her commission, we do 0.0325 times 256,000. All right, so we bring our calculator. Clear 0.0325 times 256,000 gives us a commission of $8,320. Now, by the way, if you think that that's a lot of money for selling a house, then consider the sports agent who goes out and, helps LeBron James get a new contract and gets 5% of that, right? That's going to be a huge amount of money. Keep in mind that people who sell houses for a living, they may sell 3 or 4 houses a year. That might be it, because it takes a while to sell a house. So although this is a chunk of money, it is only 3.25 or 3.25% of the actual sales price of the house. Right? The customer themselves are getting to keep 96.75% of the proceeds. All right, so commissions, simply money that one gets for selling something for someone else. Let's take a look at number 7. Actually, it's exercise number 6. An investment firm charges a commission of 2.5% on the increase in an investment's value over the span of a year. If an investment started at $5,200 and increased over the span of the year by 4.8%, then what was the commission charge? All right, now this one's kind of tricky because there's 2 things going on here, right? There's an increase in the value of this investment by 4.8%, and then there's a commission of 2.5% on the increase in value, all right? So, what I'd like you to do right now is pause the video and see if you can answer this question. It's a multi-step question, but see if you can figure out what the final answer is. As a little hint, it's not going to be a huge number, not like the last one, right? This is actually going to be a relatively small commission that is paid to this investment firm. Take a little bit of time now to try to figure it out. All right, so you might be like, well, I don't know, which number should I take and multiply by which percent? Well, again, a careful reading. An investment firm charges a commission of 2.5% on the increase in investment's value over the span of a year. All right, so the first thing I really need to do is figure out how much this investment increased over the span of a year. And they tell me that it increased by 4.8% over the span of the year. So the first thing I'm going to do is I'm going to figure out what 4.8% of my $5,200 is, right? And that's going to be 0.048 times 5,200, and let's figure that out on our calculator. 0.048 times $5,200. All right, so that gives me $249.60. Okay, now let's just make sure that we know that's not our final answer. What that was the increase in the investment over the span of the year. This was the increase, right? So now our commission is going to be 2.5% of that increase. In other words, I need to now find 2.5% of this number. All right? So that's my next step. 2.5% of $249.60. So again, very similar to my calculation before. I'm just going to do 0.025 times $249.60. And this is going to be equal to what? Well, let me clear this calculation out. Come on, nope. Let me bring this up a little bit. 0.025 times $249, move this a little bit, and 60 cents, and that's going to be $6.24. Now, that's a very small commission, right, compared to what we saw in the last problem. And that kind of makes sense because investment firms are managing a lot of money for people, right? Lots of different people, lots of different investments. So they're making all sorts of little commissions like this, and then those eventually add up and they're able to make a salary, so to speak. But this is an interesting way that investments work in that you give a bank or an investment firm or something an amount of money, right? Then at the end of the year, assuming that that investment has increased in value, those people then get a little portion of the increase in value. They don't get a little portion of the money that you invested. They only get a little portion of the increase in value because that's the point. The point is that they're saying to you, give us your money and we'll make it increase in value, but we get a little chunk of that increase. What's the little chunk they get? 2.5%, right? You get to keep the other 97.5%. All right, let's keep going. Let's do one more problem. Here we go, exercise number 7. Roberto takes out a loan for $18,000 to buy a car. After 1 month, he is charged an interest fee of 0.75% on the loan. If he then makes a payment of $300, how much will he then owe on his loan? Carefully think about how to find 0.75% of the $18,000. All right, so this is the way loans oftentimes work, especially loans for cars and loans for houses, right? They give you a loan. After a month, they charge you interest. So they take a percent of that loan and then they increase how much you owe them by that amount. But then you make a payment, a car payment, a home payment, a whatever payment, right? And then that takes down the amount of money you owe. So what I'd like you to do now is I'd like you to pause the video and try to figure out how much Roberto is going to owe on his loan after that 1 month of both interest and payment. Pause the video now. All right, well, the thing that we have to be the most careful about in this problem is this 0.75%. The last thing you'd want to do is multiply 18,000 by 0.75. Then you'd be getting 75% interest and never take a loan with 75% interest. That would be horrible. You'll never be able to pay it off. All right, we need to find 0.75% of 18,000. All right, now we can do that. All right. We just have to be careful. And again, let's just get 1, 2, right? That's going to be 0.0075 times 18,000. All right, so the interest that Roberto is going to get charged is going to be 0.0075 times having a problem with the 8. 18,000. And that's going to be $135. All right. So again, let's just talk about this for a minute. At the end of 1 month, this $135 is going to be added to the $18,000 that Roberto owes to pay back the loan. That's the problem with interest, right? The longer you hold on to the money that you were loaned, the more money you actually owe, right? They're not going to give you that money for free. So what Roberto owes, right, is going to be $18,135. But then he makes a payment of $300. So that ends up being deducted from what he owes, in which case we can easily now figure out how much he owes on the loan by subtracting off the $300 payment, and Roberto will owe $17,835. By the way, one of the very important things here, especially when you think about borrowing money, is the fact that after 1 month, Roberto actually does owe less than what he started owing, right? If what he paid, that $300, was less than the interest, then Roberto would never pay off this loan. It would just keep getting bigger and bigger, because in month 2, we would be taking this number, multiplying by 0.0075 to get another chunk of interest that we'd add on, and then we'd subtract off our monthly payment, et cetera, et cetera. Normally, the monthly payment has got to be bigger than the interest charged. Otherwise, again, you will never pay off the loan. Like ever. It just won't happen. It'll just keep getting bigger. All right, let's move on and wrap this up. So in this lesson, we didn't learn anything new in terms of the mechanics of doing percent problems. What we did learn was a few new applications of percent, and they were kind of different, right? The first application was percent error, or just how much error is there in a measurement that we make typically within the context of like science or engineering or something like that. The second thing that we looked at were specific types of percents that get charged in terms of fees, specifically interest on loans and commission fees that are paid to people who sell stuff for us. All right, now I know a lot of these things you're not going to experience in the real world for, I'm hoping, at least 6 years, if not even longer than that. But eventually you're going to have credit cards. Eventually you're going to take out loans in order to buy a car or get an apartment or a house or something like that. And at that time, you'll have to understand percent well enough to make sure, think about that last problem, that whatever payment that you're making every month is at least lowering the amount that you owe to the bank or to the credit card company or wherever. All right. For now, I just want to thank you for joining me for another NGen Math 7 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.